Alright, so here we're going to go over the assembly of the OutRun Mark II, starting with installing some zip ties here, and these are going to help retain the wires for the weapon assembly when everything is fully installed. We're just going to start them here. We're going to put them through and just start them a little bit. That way they stay, not snug them all the way down yet. There's the first one, kind of trying to show you how we orient them. Do the same here with the second one, but further back in the chassis toward the electronics area. And these can be done after the robot's fully assembled, but it's much more difficult. So doing them early is the easiest way to make sure that these get in there without, being super difficult. Now we're going to jump on to the wheel assembly. This is a real easy process also. We're just going to take the flanged bearing here and push it into the wheel. That's all there is. Repeat that process. That flange helps retain the wheel on the bearing, and the flange also is caught and captured by the screw on the axle, so it's all held from pulling off. Now we're going to check out our drive motors here and get them installed on the drive motor mount plates. Go ahead and get these out. These are the repeat tangential drive motors, the Beetleweight sized ones. We've got, should be 4mm M3 screws here. And we are going to use our aluminum mount plates. Line those up, make sure the wire is going back towards the shorter end. That'll be the rear of the robot, but it's towards the shorter end of the mount plate. And this is important. And then we're going to line up the mounting holes here, and we'll start a screw to hold everything in place. Go ahead and put some Loctite on there. Blue Loctite I like to use on most everything. That way it can be removed when needed, because combat robots break. That's kind of the whole thing. They're going to need parts replaced. But blue will help it from shaking loose. So we'll go ahead and get this lined up. There we go. Tighten it down there. Make sure that our other holes are also aligned. We're going to Loctite these as well. And tighten this down. Fast forward this a little bit because I think y'all know how to put a screw into something. Loctite. Tighten it down. And then we're all set on that drive side. That's how you assemble a drive side. We'll do the other one again real quick. Same exact process. All right, now we have the remainder of our drive hardware. Now this is our axles and the axle mount bolts for the front and back. And then the actual drive mount plates we just attached the motors to, those drive assemblies, we're going to use those too. These smaller screws I'm putting back in the bag are for the outside of the axle to retain the wheels. We don't need those yet. All right, so take one of the mount sides. Go ahead and run the wires through this small channel here by the rear axle port. And those will go to the inside of the robot. Go ahead and give it a little bit of a push just to help make that angle a little easier. Push on the wire guide there. And then we'll get the motor into the circular socket on the outside of the robot. And you'll see now where the drive mount plate holes line up with the hardware here. So we're going to take the hardware, one of the two longer screws, and feed it through from the inside of the robot. It's going to come out right here to mount the rear axle. You take a screwdriver, usually a longer handled screwdriver makes this easier. You can kind of just lock that screw in place. Add some blue Loctite here, and then we're going to take the axle and thread that on there. We're going to snug it down pretty good. We don't want it moving. This plate not only keeps the motor in place, but also kind of ties together some additional rigidity in the frame. So you want these things tightened down pretty good. So we're taking one of the shorter interior axle screws, going through on the front. Use a shorter one so it doesn't interfere with the weapon assembly. Go through from the front. Use that same trick of using a longer handled screwdriver to keep the screw in place. We'll add some blue Loctite here. And then we're going to thread this axle on. And snug it down as well. There is a drive side installed. Alright, we're going to do a little bit of test fitting of parts here just to show you guys how these are going to go in and to make sure we got our wire lengths right. So go ahead and get everything in here as it's going to be electronics wise. And then we'll start getting everything installed permanently. So we got our switch, our power distribution board, receiver. Those can be made smaller, but that's how they come. Our got our weapon speed controller, or ESC. We're going to go ahead and tuck that away for now because we're going to do that installation a little bit later when we do our weapon installation. We've got our two drive speed controllers here. And then, of course, we have our battery, our BEC, battery eliminator circuit. This drops voltage down from the battery voltage to the receiver. And we've got our wires inside the chassis here for our drive. We're just going to kind of eyeball the right amount we need to get over to where we want the drive ESCs to sit, and then clip these off so we don't have so much extra wire taking up room in the chassis. Cut them off there. It's always nice to have some extra wire around, so I would just throw those in your box, in your toolbox there. But we'll strip these back, get them ready to tin. All right, then we're going to go ahead and tin the wires, which is just adding some solder to them. Adding fresh solder to anything helps it to flow better. And these aren't soldered at all yet, so we're going to tin them for the first time, make good connection to our speed controller here. So we're going to tin these 3 pads on the speed controller where the motor wires go. I'm using the biggest tip on my soldering iron that I have because it helps get the large pads tinned quicker without having to apply heat for as long. And then we're going to hold it in place here and go ahead and melt the solder and put the wire in place. You can use helping hands for this, or you can just kind of work with the natural bend of the wire and hold the ESC in the right place. I want to make sure there's a good connection there. And there we go. And that's one down. And we're going to repeat the process with the other side. We kind of are going to bundle the 2 speed controllers together similarly. So we're going to actually run this side a little bit further for the drive wires so that the speed controllers can kind of line up next to each other with their receiver side wires going out the same way to the receiver. All right, now we're going to tin and solder the Lynx power switch. I recommend making sure that the screw is engaged in both sides when you do this. This will help with heat dissipation so you don't melt plastic. Pretty much you want the switch in the on position when you do this. All right, then I'm also going to do a little bit of kind of hand measuring here. So we're going to take the negative side of our incoming power plug and run that through the switch. So we'll go ahead and cut that off about halfway down. We're going to tin all the loose ends after stripping back the wire we just cut. You tin this end that was already there as well, just to make sure it's fresh. And then don't forget to put your heat shrink on any connection that you're making that is going to have a closed end on it. So I have the connector on the other end of this piece of wire, so I have to go ahead and put the heat shrink on before I solder. That way when I'm done soldering, it's on there and I can just slide it down. You can use hot air, you can use a lighter, you can brush over it with the soldering iron, any number of tricks to shrink the heat shrink, but I have a hot air gun here, so I'm going to use that. Now this wire has an open end on the other end, so I don't have to put the heat shrink on until after I'm done, but I will go ahead and do that now and shrink it up. This is going to insulate those connections and provide some strength, some strain relief, so that the solder joint itself isn't having to hold all the strain. Now we got those two steps done, we'll jump to grabbing out our power distribution board here. This is probably the soldering portion that is the most difficult of all of them, because these are effectively just two large pads, one positive, one negative. They're split apart visually, but they're all connected electrically and thermally. So you have, when you go to solder to one of the positive pads, you're heating up all the positive pads. And the same with the negative. You go to solder one negative pad, you're heating up all the negative pads. And so you really want to get good with timing to attach something to one pad without heating up the next pad too much that it reflows and you lose your connection there. We're going to tin the output pads here on the BEC. Sorry, the input pads. The output pads already have the connector on them, so get the input pads tinned up and ready for our power wiring from our power distribution board to the BEC. Then we're going to tin these wires as well. As you can see there, we got the input side, we just tinned, we got the output side with the wires already soldered in place. We're going to go ahead and solder this to the power distribution board. There's a small series of pads labeled BEC on the power distribution board. Go ahead and put them there. It's the smallest pads. This requires the least amount of power. Again, make sure you keep your polarity correct. Make sure you're positive. On the power distribution board is going to your positive on the BEC. Check for good connection there. And we're going to slide our heat shrink over for our BEC. Then go ahead and shrink that up. That'll prevent any kind of debris from shorting the BEC. Kind of like to pinch down the end there. Make sure it's good and tight around the board. And then we'll move on to the power connector. We're going to do the incoming power on the BEC on the same side, the incoming power on the power distribution board on the same side as the BEC connection. It's got singular pads here. They're a little bit larger. It's easy to go ahead and put this over here and then do all of your outgoing power from the board on the other side. Alright, again, test to make sure you've got a good connection. I'm going to grab some more heat shrink and go ahead and slide this on this assembly now, but slide it back over the wires while we can before we make any other connections. And then we'll go ahead and tin this side up some. This is when you have to be careful. Like I said before, they're all connected, so heating this up too much all at once can cause one of the connections on the other side to break loose. That's why I went alternating from positive to negative pads when I was soldering it, so one side didn't get too hot. Look, you've been trying that when it did. We popped loose our BEC connections here. Now we can get the weapon speed controller back out here. Tin the wires on the power side here. Get ready to solder those to the power distribution board as well. There are a lot of ways to do this. A lot of people do them coming out, kind of in the orientation of the pads. I like to use it kind of as an inline. It makes heat shrinking it easier, so you kind of see the way that I'm doing the soldering here. I'm stair-stepping them further out on the pad as I go, soldering the power connectors for all the speed controllers there. And doing it from this angle kind of just allows it to heat shrink easier, everything to stay a little bit smaller. You absolutely can have them coming in from the sides. You'll just end up having to electrical tape it instead of heat shrinking it when you're done. If you're comfortable doing that, do it that way. I prefer this method. I'm going to tin the pads on the weapon speed controller. Alright, now we're going to actually check out the process of installing the weapon assembly here. We're going to press these ports into either side. You want to put the one with the notch that I put in first on the side that has your zip ties, because that's where the wiring is going to run. Then we're going to take this spacer, run the wires through one of those oblong slots. They'll slide down to the back of the motor stator. It'll match up. You'll see the geometry matches up there with the back of the motor. You're then going to line it up so that the wires go into the slot on that weapon support. Just like so. Take your time with this. Then you'll take one of the 4 provided M4 screws. I believe these are 20 millimeters. Start it in one of the holes. I like to start it with one of the 2 that is right by the wire. It helps kind of keep everything in place. Get it pretty tight, but not all the way tight, because having a little bit of shift between that black spacer and the motor is helpful for getting all the rest of the screws started. It's a 2.5 millimeter hex, by the way, what you'll need here. Your mileage may vary on that, though, depending on the screw heads we have at the time. Alright, and get those tightened down. Now we're going to install the dead shaft. It starts on the side that the motor sits on, and it goes to the opposite side. So we've undersized the hole on the weapon support on the opposite side, so that when you install this dead shaft, you're going to cut thread into that weapon support, that UHMW weapon support directly, making that whole front piece, weapon and weapon supports, a solid assembly. Here we've got a bearing, 3-part bearing you're going to install on the far side of the dead shaft between the motor and the weapon support. Sorry, between the weapon hub and the weapon support. A bit flex in the frame there, so you can kind of flex it out. Get it lined up, and then push your dead shaft through there. And you're going to tighten it down, cut those threads into the far weapon support. Sometimes you need to back out the screws holding the motor in place a little bit, just to make room for the head to get all the way down in there, and then it kind of sits below their level so they can seat back down. You can check for free spinning there. Now do make sure when you put your weapon assembly in initially, you run those wires through the zip ties that we put in very first thing, and then into the chassis of the robot. There's a hole just past that second zip tie. And then you can pull those snug and clip them off. The zip ties, not the wires. Leave the wires. It'll just snug back up any of the screws you had to loosen a little bit. I ended up popping that axle off to give me a little bit more room there, but that was more for filming's sake than anything else. If you have to do so, go ahead and just put it back on at that point. Then we have this adapter for the far side. It's a little plate that's going to help you keep your weapon support attached to the printed frame. Spreads out the force of any kind of pulling greater than any nut would on the far side of the dead shaft. Alright, now we're going to slide the heat shrink over the weapon ESC. Go ahead and solder those wires on from the weapon, but as you can see, we can trim them some, get some space savings. I'm going to strip these wires back. Now we'll tin them. And go ahead and solder them to the pads on the speed controller. Making sure you get a good connection there. Now we're going to mount the wing here to the switch to this wing here. It's a carbon fiber plate that goes across the front top of the electronics enclosure. funnels air across the electronics for cooling, and it also the link switch mounts to it, the power switch. So we're going to line up the hole here, kind of see which way the wire wants to go naturally, and then go that way, line up the hole, put this little number 4 screw in, snug it down. And that keeps the switch aligned to that hole there. And we'll slide this heat shrink over the speed controller. For all 3. And I've just got the 2 drive ESCs connected here to the receiver, and we're going to test the turn direction of each one, response from the radio. We're not going to hook up the drive or the weapon speed controller yet. The weapon speed controller is not hooked up. Before we put the wheels on, we're going to test the rotation of the drive. As you can see here, we got the BEC going into this first slot on the receiver, and the drive connectors are going on the last 2. Go ahead and hook up the battery. See the receiver's on, and turning on the radio. See if the shaft of the tangential drive motor is rotating backwards, the wheels will rotate forward. So that's how you want to check these. You want them to be rotating backwards when you push the stick forward, vice versa. And then when you turn, you want it to turn. If you hit the stick left, you want the left side to turn the wheels backwards and the right side to turn the wheels forwards, and vice versa. So we want to check for that. And then you can make sure that it turns correctly through mixing. So I'll show you how to do the mixing real quick on this FSI 6 radio. Just follow me here. Go down to mix. Mix 1, you got it on. 2 on. You can pause it and look at the settings for each one there. You'll make sure you go to failsafe here as well. I'm kind of speeding through. I kind of expect you guys to, when you set up, go through and check this out on repeat and double check that everything's right. This is super important. Turning your channel 13 failsafe on. And double check that it saves. Alright, so now that we know that these are turning the correct way, we can shrink up the heat shrink on the drive speed controllers. We have not yet tested the weapon speed controller. We need a safety box for that. So I'll do that off screen, and then I'll go ahead and shrink that up before we get it closed up. But you need to test in the safety box at an event. If that's the first place you can get to one, then just leave it unshrunk until you get to an event to test the rotation of the weapon. And be prepared to do that there. You do not run the weapon outside of a safety box. Now we're using these M3 screws to hold down that wing. At the bottom, we have two different length M3 screws. The short ones are going to go in the front, the long ones in the back, and that's so we don't interfere with the drive motors inside their little chambers there. Get those all snugged down. It's a titanium bottom plate. Now we're going to look at the AR 500 rear armor insert. It slides into this pocket here, and you just push it in. I take a flathead and kind of work it all the way down in there. It should go past the lip here. Then I'm kind of pulling that lip back up over. That retains it. Prevents good hits from the rear from getting your electronics there. You got that armor piece. And then we have our forks here. Also AR 500 forks. We're going to use some M4 screws. I kind of chamfer the edge with the Phillips head just to let them start easier. Just screwing directly into the UHMW here. So we line it up. I put the pivot screw in first. I don't snug this all the way down. I don't snug either of them all the way down. You want the forks to be able to float. They're designed to kind of hinge down, but this slot that this screw is going into is designed to kind of keep it floating in a certain area so you're not getting it stuck underneath you, if that makes sense. And we'll do the same thing on the other side. Now we're going to get all the electronics fit into the chassis, ensuring that nothing is bent to where there's a lot of strain on a connection. The speed controllers fit really well up front. We generally put the battery in the back. The receiver goes up front as well. Again, this is just my method. If you have another method that everything fits in there that you prefer, go with that. This is just the way that I've gotten them to fit in there the easiest. Once all the electronics are in there, we can go ahead and attach the lid. We'll use the 4 M4 screws to attach the lid here. And now we'll go ahead and install the wheels. It's pretty easy. You just slide the wheels on the shafts. You have to tuck the edges of them around the tangential drive motor output shaft, but they will sit against that output shaft. That's what makes it run. And then once they're in place, go ahead and secure them on the axles with the screws that we set aside earlier. And repeat on the other side. Now you have a complete OutRun.